welcome back. There are a few more things we want to talk about. One of the things are the idea of loops. Now, we've spent plenty of time already kind of talking about the for loop, so it'll be a little bit of review. But we also have the while and the repeat loop, which we haven't seen yet. Here we have 3 examples of the 3 different kinds of loops. And the end result of all of them are that you're going to get 1 to 10 printed. If we start with the while loop, you'll see that the way that it works is it evaluates a condition to decide if it should execute the loop. So x equals 0, while x does not equal 10, do the following: increment and print. So we start at 0, 0 does not equal 10, that is true, do the loop, right? And so as you increment, right, it keeps asking, is 1 not equal to 10? That is true, do the loop. Is 2 not equal to 10? That is true, do the loop. It will keep running until it gets to 10 does not equal 10. That's false, stop the loop. All right, that's the while loop. On the other hand is the repeat until loop. The repeat until loop is kind of like the golden retriever of loops. It's going to, as soon as you walk to the door, it's going to take off. It's going to knock you to the ground, bolt out the door, run, go find a stick, bring it back to you, and then say, hey, can we do this again? Huh? What about it, Dad? Can we do it again? The repeat until loop always executes the loop at least once. And then it checks to see if it should do it again. The while loop checks before it starts. The repeat until loop checks at the end of the loop to see if it should do it again. There's subtle differences between them, but they both involve some sort of logical interaction and calculation to decide whether they should operate. For me, I don't like thinking that hard. I just don't. I don't like thinking that hard. And so I almost always gravitate towards the for loop because I can definitely, clearly see exactly what it's going to do. For I equals 1 to 10, counting by ones, as we've already said, it's so straightforward. And one of the things to notice about the Lua formation of the for loop is that you are creating a local variable right there in the creation of the for loop. You don't need to have an external variable already created that you're using as the iterator. It's built into the syntax itself. Additionally, the idea of iterating the iterator, you don't have to do that. That's also assumed, because remember, Lua is all about removing as much syntactical friction as it can, right? If you're writing a for loop, everybody knows that you're going to want to iterate. Now, you can choose what you want the iterating step to be. So by default, it's +1, right? By default, you are counting up by 1. You can take some time and play for yourself to try out counting by 2s, counting by -1s if you want to count down. There are different ways to formulate the syntax, but the most general approach is as you've seen here. For I equals, start at 1, go to some other number, and count by ones, do the following. There you go. I like the for loop. It's straightforward, it's simple. I don't have to think that hard, and that delights me. Now, many of you are noticing this note at the bottom of the page. It's an important note. It is true that Q-SYS will, in an act of self-preservation, it will prune scripts that have too many executions in a row, because maybe it's an infinite loop. Maybe it's just a loop that's running for too long. One way or the other, Q-SYS is going to protect itself and shut it down before there's any negative consequences. I mean, we all remember the old days of when spreadsheets used to sometimes run too long and then would crash and cause the whole computer to crash. Nobody wants that. Q-SYS doesn't want that. And in fact, if you want to know more about this particular situation, there is a whole control quick start where we take a deep dive into explaining what's going on here. But for now, we're going to leave it at this. Q-SYS prunes things that take too long to execute. In fact, let's take a moment and actually look at a bad loop and see what this looks like in the real world. Let's go back into Designer. And I am going to drag out a text controller. And there we go. And this guy's blank because we don't need anything. In fact, we're going to get rid of him in just a second. So let's open. And let's write an intentionally infinite loop. While true, do the following. What do we want to do? Let's have x equals x plus 1 print x. I need to define x here. We're gonna let x start at 1. So there we are. While true, do the following. Increment x, print x. All right, cool, and go, and boom. There you go. I was able to get approximately 28,000 loops before my code was pruned. Here's what you need to know. If you ever see this error, it means exactly what it says. It means that you have exceeded the execution limits, meaning you have exceeded the number of Lua executions that we permit. This is a number, it's a big number, and remember, this is Q-SYS taking care of itself. If you ever see this, there's really only 2 reasons that you will ever see this particular error. One is by writing a loop like this. An infinite loop will put you into this particular ditch. A loop that doesn't end in a timely fashion will also put you in this ditch. Now, one of the places where you will probably maybe come across a loop that just runs too long, that would otherwise end, is if you're working with really big JSON data sets. If you're working with a really big JSON data set, consider using the Rapid JSON library instead. For more information about that, see the control quick start that I mentioned a minute ago. We'll go deeper into that. But for now, this is enough. I really wanted you to just see this error and know that it existed and know why it existed.
You could also trip it, right, if you have a function that references itself within the function.
Right.
That makes an infinite loop.
Right. Right, Nate, that's called recursion, which is a really awesome trick. And but we're not going to get into that at the moment. I really wanted to just make sure that we saw this error and we knew what it was and you weren't thrown off by it if you ever saw it.